Hey guys, I'm Alex from Deep Cycle Power. Welcome to a new video. I'm going to go briefly about the logic behind the MegaCell Charger. I'm working on implementing a state machine flow for the new charger. We had something that's similar to state machine, but it was not properly designed to follow the transition and the rules, and being able to control the states, being in different states, control the transition, make all the checks. So it was similar to a state machine, the firmware that we had running, but now it's going to be much more organized in terms of that. So let me show you what I've been doing for the past days. First, I had to organize all the states that we're getting into and all the events. Still have to finish this up. So the first thing will be not inserted. That's when the cell is not present. Voltage is under the threshold for cell detection. We get the new cell inserted. We check the chemistry. I'm introducing a new state now to check the chemistry that is set by the user and compare it with what results we get by measuring the voltage. For most of the cells, if they are above 3 volts, for example, we can determine that they are lithium-based cells. Then we have to get the user input about the voltage to charge those cells, because if it's lithium phosphate, that will be a different charging voltage than lithium ion. So we have a LVC cell, that's low voltage cell. We at the new cell inserted, we check if there's voltage under the threshold. We will treat it as a low voltage cell. We'll charge it with lower current until it reaches the minimum voltage for fast charging. We get the regular cell. Conduct calibration, this is a new state. This is a new state that's getting implemented in the professional version. Is going to check the resistance of the wires you're using for external accessories, because we are focusing a lot on getting the device as calibrated as possible. So we had introduced this step. We have now the ability to switch between onboard voltage reading and accessory voltage reading. So that's what we are going to do in this step. We have conductor calibration, and I'm going fast into this so I can get into the state flow and show you the logic behind this and simulate it to see what happens. LVC charge, it's charging the cells when they are in a low voltage. Regular charge, charge rest, charging failed, charge check, volt drop check, charge, a normal charge. This is in case we get termination with a high current, or if we are going to switch to a failed charge, failed store, charging failed. If we get the cell too hot during charging, we are going to attempt 3 times. Let the cell cool, because sometimes when the cell is really discharged, when you're starting it, the first time you are going to get some hit from it, but if it happens 3 times, then that cell is not good for using. We have ESR reading. I'm going to focus on getting this ESR reading. I got some new tools to measure the ESR properly, and I will try to model an algorithm to be as close as possible to the results we're getting with AC. I'm not sure how close I will get until I start working on that, but I will do my best to to get it as close as possible. We'll be using the volt drop method, so we'll apply a current, but on the new version I will be able to set the current to 1 amp, and that should make the calculation better. Store charging, have check store action, fail store, stored, disposed, and the error. We also have the transitions. I still have to update this file with the new transitions because I worked in the Stateflow, but the events will be pretty much the ones that I listed here. So we have events when a cell is inserted. These events are actually state transitions. So when an event is hit, we check that it checks out. We are going to return that the event is valid, and then we can proceed with the transition to a new state. So I'm getting quick into this because I don't want to make this video too long. And I started using Stateflow, which, if you are into any kind of automation, this is a great tool to be using. You don't have to know software development to be able to create your state flow chart. This can actually create code as well. I'm not going to generate code from this. I'm just using it to test my logic, and after that I'm going to implement it in software. So we have a few parameters for the input, and these are the parameters for the output: the capacity and voltage, cell temp, hot charge. So let me get into it and show you what is going on here. So when a cell is not inserted, we're going to reset the parameters. We then switch. When cell volt is above 0.6 volts, we switch to a new cell inserted. We check the chemistry. Here I did not add the entire logic here because I will have to get some user input as well on this, and I don't want to bother doing this in Stateflow. I just added chemistry 0, which is lithium ion for now, and now we have low voltage threshold, and here will be, for these chemistries will be holding the values, the default values for testing a cell and checking different parameters for it, for like low voltage and all that. And we'll have the default chemistries, which will be lithium ion, lithium phosphate, and LTO, lithium titanate oxide, or something like this. I will probably add the high voltage lithium or something like this. It's like 4.4 volts. The chip can do that, the IC for charging. So let me actually simulate a charging to show you why is this tool so useful for checking logic. I can simulate a heater as well, a heater cell. Alright, so now if I'm going to simulation, I can step forward. You can run it and it will go to the state, but I like to go state by state. So a new cell is inserted. We check the chemistry. We decide that it's a regular cell. We go to regular charge. We skip the charging because the cell voltage is 4.2 volts. Volts drop check. Here I have the time. If you see this variable here, is going to wait 5 minutes. Now it's 5 ticks, but it's going to be 5 minutes in the real world. We'll be able to set different timings and all that, but So let's say we receive a cell that's 2 volts. Let's step forward. You see that it got the low voltage cell route because the chemistry is set to 0, which is lithium ion. I'm going to low voltage charge it, and if you see, I will increase the voltage every tick here. The end voltage is the variable that's updated. So it got over the low voltage threshold, and now it moved to a regular charge. Here it shows that it can go into this direction, but this will not get through because we are not storing it yet. So all right, so now it got to charge check, volt drop test, and we get charged. All right, and let's test the discharge as well. If I'm going to do the discharge at 2 volts, is going to get into low voltage, and there's no discharge. I already tested that, and there's no point in showing you. All right, so we get every state starts with this, no cell inserted, and when we detect that the cell is inserted, we go to regular cell, we go to discharge, you see that the end voltage decreases and it goes to discharge. And these are the basic functionalities for the state machine, for the cell state machine. And what's going to make my life easier when programming the new feature is that each cell will have its own state machine. And on top of that, we're going to have a macro state machine that's going to create different scenarios, like the measuring capacity that requires charging the cell to a certain voltage, then discharging it, measuring the capacity all the way down, and then charge it. So there's no point in creating all these states if it's just a macro that's going to send events. Okay, it's the manager. The macro manager will look over the states of the cells. So each cell will have a state machine and a macro management state that for now is going to be idle for the regular charging and discharging that you do, and is going to go to start to measure capacity state. And that's going to send events. It's going to get through the stages of start charging, and when I hit start charging, the state machine of the cell is going to manage everything, like check the voltage, check the chemistry, and all that. So we don't have duplicate code when implementing all the macros. Is going to be a high-end management way of the cells. So we're going to be able to send events from each transition. In the future, I might be able to communicate directly with the MegaCell Charger to the database, and this way we'll remove the pooling from the software, like pulling every second to get new data in and to store it to the database. We'll have the charger pushing data when we have a new event happening, or if we can set it default to 5 seconds to update the database, or whatever interval we want. But that's going to to make it easier to control and monitor multiple chargers at a time. MegaCell Monitor supports up to 80 chargers per device right now, which is enough, it's impressive. But if you aim for 1,000 devices, for example, that will make a bit difficult pulling data from each device, like sending requests and then waiting for data back. Instead of that, you will communicate directly with the database. You don't have to communicate with the charger. You just set something in the database, the charger reads it when it's regularly pulling information from it, and this way we make the software, the monitoring software as well, much simpler to use. So yeah, that's the state machine that I have right now. I still have to check every state, and I will start implementing the following week all the states. I found a great architecture for implementing state machines with C++, with the Arduino code. Got some library that works very well with this kind of state machine. I tested, everything works fine. I was able to check the states, like cell inserted, switch between a low voltage cell, high voltage cell. In case a cell gets depleted for some reason, it's self-discharging, it will switch to a low voltage state, and it's much cleaner now to keep adding new features, because I was checking the code, and over time it got very elaborated with the new features and all that, and it was kind of hard for me to add on top of that the new things I wanted to add, like the conductor calibration, setting PWM for each cell for discharging, setting charging voltage to each cell. It was it was a bit clogged, I should say, because it started simple, then we kept adding on it, and the architecture was not properly set at the beginning of development, because we wanted to test that this works, that people want it, and now we need to do it the proper way. It takes longer. It's a bit more thinking to do, like planning ahead before you start coding. That's going to make life easier when you have all the logic laid out. You can simulate the states, see what can go wrong, because you don't have this level of debugging when implementing code. You need to implement your debugging as well, and adding code for debugging also makes the code look not very clean. So that's all for the state machine update. About the production, I got in touch with the factory. Like I said before, I launched the order, and now I'm waiting for 5 pieces to be delivered. And the factory said that in 2 days we'll have the PCB ready, and by 26 August I should have all the 5 boards for demo, like for prototyping. The final prototyping should be ready. They ship it to me. I give my okay if all the functionality is there. I tested the previous prototype for the MegaCell Charger. I tested that we have support for 12 volts now, and it works directly without having to do any modification to the board. Didn't had any issues with the design so far. So now the last thing that I've added is the PWM per cell for discharging, so I will be able to implement constant current and constant voltage when discharging, and also I have access now to every charging IC to set the charging rate and charging voltage, charging current and charging voltage. So we'll support different chemistries for all different cells and all that. So everything's going great, guys. I'm working on this. I'm getting things done, finding the best ways to implement this. If you have any suggestions about any states or something like this, you can let me know. And the nice thing is that once we implement this architecture, we'll be able to modify it in the future and customize it with different states, different checks, different tests that we want to do. We just keep adding events and states, and we'll be able to control that from the macro management. We can create macros for everything. It will be for cycling a cell, that will be another macro. And yeah, I think I'm very grateful that I got the chance to rework this and make it this way, so we can upgrade in the future the software. We can move to the ESP32 as well, which will be more processing power on that. Can do different things, but one thing that's needed is your support. If you want this to happen, if you want this project to evolve, and you're getting into batteries, get one of the MegaCell chargers. You get the best deal now by getting the pre-order. You get it at 197 euros. I'm not making too much profit on that. I need to get the connectors, solder them and all that, get the boards which are pricey now because it's a small batch. So I'm not in for the profit for the prototype batch that we're doing, pre-order batch that we're doing, but I want to get it in your hands and get your feedback, get it to see how it works. And I promise you that I'm not going to ship any more devices that have issues with discharging and charging. I'm checking them personally now. Everything goes through me. There's no other bridges that can be disrupted. Now that I control the hardware development and now the firmware development for the charger as well. I started working on the code for a Python library. I'm sending events now to the charger through the Python library, and that I will make open source. I will put it on my GitHub once I get a version that's reliable. By the end of this month, I should have that library uploaded as well, so you can use it for the old charger with a few modifications for the communication. I will try to not make the communication incompatible with the old version, because I don't want to have too many modifications to add to the MegaCell monitor. So the new library will have the checks for the things that it's setting. If the device is older, it's not going to affect the events that we're sending from the library. So yeah, that's all, guys. Again, go to the deepcyclepower.com if you don't know what it's about and you watch this for the first time. Get there and get the MegaCell charger, the pre-order one, for 197 euros. In the future, it will be more than 250 euros. I know for sure that, because I have to get something from this project, so I can pushing it. Paying for the advertising and all that. It's a lot of work to get a project there. I'm sure that some of you know that. I've got all the support from some of you. Okay, we know that there's work to do. We're grateful that you're doing this. Thank you very much. Thank you for what you provided so far, and that makes me push further, and knowing that this is useful, this is something useful, and with the new modifications it will be something that's close to perfection. Hopefully we'll get every aspect of this polished. That's the word I want to. I kept using it, and I got fixated on this. Like, I have the stone, I need to polish it now, make it perfect, make it shiny, and make it work great. The shiny is not just in the aspect of the case, for example, or the physical aspect. It's also how you're using it, because right now when you start using it, you'll get a few bumps that you need to get over it, so you so you can actually use it. I want to smoothen those bumps, get it as easy as possible. I'm going to modify the menu that you're using for the push button, make it a proper menu like you see on the GoPros. They have a push button. They have two buttons, but most of the action is done with one button. So I will get it like you set the chemistry for the charger. You set the action easier. You'll have the option to set the Wi-Fi, so you get into the first time you start the charger, it's going to start like a regular device. You can use it right away. Don't have to wait the time to connect to Wi-Fi, go into Start Portal. These are things that bothers me as first user. Now that I got used to it, I know the logic, I know I need to connect it to Wi-Fi. There's no better way to use the device than connecting to Wi-Fi. But as a first start user, you need to get in as fast as possible. Okay, I want to start charging now. I want to push button and things happening. So that's what I'm going to do. It's polishing this device, make it great, and I'm not going to add hardware versions for a while. So if you're getting the pre-order now, you're getting the device that's going to have all the features software wise and hardware wise. That's why I have a delay of 1 week, because I got a new thing added. That was the discharging for the cell, different cell. I thought first, okay, I will add it after that, and I was thinking like the big companies, that's another upgrade, will make people buy another version, but that's not me. I thought, okay, I'm going to piss off the 30 people that already ordered now, and it's not like a $10 device that you throw there. It's 200 euros, $230, 225 or something like this. So I don't want to piss people off adding new versions of hardware and make that obsolete. And so I added 1 more week of delay. I will be shipping by mid-September, but I think that will be worth it for all of the users. Will make it worth it for their money. Alright guys, that's the update for today. Don't forget to subscribe if you're not subscribed. I'm going to keep adding videos about the MegaCell Charger and about batteries in general. And if you have any questions, don't hesitate to contact me. I'm here for any questions related to batteries, to MegaCell Charger, to the equipment I use for spot welding or other things that I do with the batteries. That's it, guys. Thank you again, and we'll see you soon.